In this atomic theory lesson, we'll be looking at the periodic table and determining the atomic number, the mass number, the number of electrons, and we'll also be talking a little bit about isotopes. Wanted to zoom in on the periodic table just to refresh your memory on some of the things that are included on the periodic table. The first thing we'll review is the symbol and the name that's given in each block of the periodic table. And I just boxed out Ni, and Ni is the symbol for the element nickel. Also, in each of the boxes on the periodic table, or blocks, we have the atomic number. So nickel's atomic number is 28. And we also have the atomic mass, which is 58.693. And every periodic table will be different. Some might have some more information on it, but this is a good one because it just gives us the basic information that we will need for this class. I will be posting a periodic table to the class page for you to reference if needed. There's also one in your textbook, and you can also find them just by Googling periodic table, and many will come up that you could use. But I will definitely attach one to the class page that will be easy for you to access when you need it for class. I'm going to review subatomic particles, but I would urge you to review the few slides before this particular slide so that you can review the scientists who were involved in discovering the electron, proton, and neutron. I'll review it a little bit as I'm going through this, but you should read back through those slides. So the electron is a negatively charged particle. It's found in the electron cloud surrounding the atom. Electrons were discovered by J.J. Thomson in his famous experiment, the cathode ray tube experiment. Protons are positively charged particles. They are a lot heavier than the electron. Their mass is heavier, and they are found in the nucleus of the atom. And neutrons, they have no charge, also found in the nucleus with the proton. And the neutron has a much higher mass than the electron. So protons and neutrons account for much of the mass of the atom. The electrons account for very little. We don't even take them into consideration when we're determining the mass of an atom. As I mentioned when we looked at the periodic table, I mentioned the atomic number, and the atomic number identifies the element. Every element has a different atomic number, and we designate the atomic number by the capital letter Z. The atomic number also equals the number of protons. Every element has a different number of protons. And in a neutral atom, the number of protons equal the number of electrons. The mass number is another item that we like to talk about in terms of atoms, and this identifies the number of the nucleons, which just simply means the number of protons and neutrons in an atom. So whatever's in the nucleus, that's determining the mass number. Then adding the number of protons and adding the number of neutrons gives us the mass number. And mass number is designated by the capital letter A. If the mass number is not given in the information or problem that you might be looking at, you can round the atomic mass from the periodic table to the nearest whole number, but mass numbers are not the same as atomic mass. Mass numbers are just taking into consideration the protons and the neutrons in a particular isotope of an atom, whereas atomic mass is taking into account all of the isotopes of an atom and taking a weighted average. So mass number and atomic mass are not the same. So let's take a look at an example using sodium-23. The 23 is telling us the mass number of sodium, so it's its particular isotope. And so if I were to write what the symbol is for sodium, I could use this isotope notation, or I could look on the periodic table and look up what sodium is. And the symbol for sodium is Na. Z stands for the atomic number, and the atomic number we can find on the periodic table, and the atomic number of sodium is 11. A stands for the mass number. The mass number is given to us in this notation, and it is 23. I said earlier that the number of protons is equal to the atomic number, so the number of protons in this particular element of sodium would be 11. There's no charge on this element. This atom is neutral, so the number of electrons is the same as the number of protons, so I would have 11. Now the number of neutrons I could determine by taking the mass number, because the mass number equals protons plus neutrons. And so I could take the mass number and I could subtract the number of protons, and I would determine the number of neutrons. So neutrons could equal the mass number A minus the number of protons. So if I use that equation, 23 minus 11, the number of neutrons would be 12. Now, nuclear notation is another way that we can write isotopes of an element or an atom. And what we would do is we would write the symbol. So in this case, my symbol is Na. The mass number goes in the upper left corner, and the atomic number goes in the bottom left corner. And it's easy to remember this nuclear notation. The mass number is more than the atomic number, and if I look at this, I can subtract the two, and that will give me my number of neutrons. So I always try to remember that the larger number, or the mass number, is at the top, and I can use this designation to then determine the number of electrons if it's written that way in any type of problem I'm looking at. Here's a practice problem. I'm going to do one of the problems with you. Krypton we'll do together, and then you should pause the video and try the other three, and then I will give you the answers to the other three. So krypton has an atomic number of 36. I'm not going to worry about the mass number right now because I want to fill in the protons and fill in the electrons, and then down here you'll see that there is a number of neutrons. So I can figure out the mass number by either adding the 48 to the 36, which is the atomic number, or adding it to the number of protons, which will also be 36. So right away we can fill in the number of protons because it's the same as the atomic number. There's no charge on krypton. I don't see a +2 or a +1, so I know that my electrons are also the same as my number of protons, so I can put 36 in there. Now, I can determine the mass number by taking the number of protons and adding it to the number of neutrons. And when I add those two numbers together, I get a mass number of 84. Now, I would like you to try and do the other three that are in this table. So pause the recording and try those. And then when you start the recording, the answers will be there for you. So let's see how you did. The second element, you should have manganese with an atomic number of 25. It's neutral, so the electrons are 25, and the number of neutrons is 30, and I just took the mass number minus the number of protons, and that gave me the number of neutrons. The next one is uranium, atomic number of 92, protons are 92, and I subtracted again. To find the number of neutrons, I subtracted mass number minus number of protons and got 143. And then the last one, the symbol is Dy. Its atomic number is 66. It's down in the actinide series, or lanthanide series, sorry, on the periodic table. It has a mass number of 164. And I got that from adding the number of neutrons to the number of protons. Now sometimes atoms will gain or lose electrons. in order to become more stable, to get that octet in the outer energy level. So ions are just atoms that have lost or gained an electron. And the first thing we're going to look at is cations. Cations are positive ions, and that means they lost an electron. Sodium has 1 electron in the outer energy level, and it's very easy for that electron to leave, so that it leaves that energy level then empty. And the energy level right below that one, the second energy level, would then be full. It would have 8 electrons in it. So let's take a look at sodium and the ion and take a look at the difference between the number of electrons. Everything else should stay the same though, because sodium and sodium ion, the protons don't change, so that means the atomic number isn't going to change, but the electrons will change. So in the neutral element, or neutral atom, the number of protons is 11. The atomic number is 11, and the number of electrons is 11. But in the ion, the sodium ion, atomic number is 11, number of protons is 11, but an electron has left the atom, and when it leaves the atom, it leaves a more positive atom, because now I have less electrons, so I get a sodium plus 1 ion with 10 electrons. So cations are positively charged ions. Anions are the opposite. They're negatively charged ions, and that means that they have gained electrons. Positively charged ions, or cations, are usually your metals, and they are on the left side of the periodic table. Your negatively charged ions are your nonmetals, and they're usually found on the right side of the periodic table. So we're taking a look at oxygen. If you look on your periodic table, you're going to see that the atomic number for oxygen is 8. That doesn't change even in the anion. The number of protons doesn't change either. If I change the number of protons in an atom, it changes the atom to a different element. So ions, the protons are not going to change, but the electrons will. So I have 8 electrons in the neutral atom, but in the negatively charged anion for oxygen, I have a 2-. That means it has gained 2 electrons. So that means I have 10 electrons to fill that outer energy level with 8 electrons and follow that octet rule. So the oxygen anion, the -2 charge, says that we have 10 electrons in that particular ion. And that's all for this video. Thanks for watching.